So for the rational function, we had to make it follow these requirements. So the first requirement is that it has to cross the x-axis at 2. So we make it x minus 2, because when we plot it, it will be the opposite and it will cross through positive 2. The second is touches/bounces the x-axis at x equals -1. So we do x plus 1. And this will just cross, but it has to touch/bounce. So in order to make it bounce off the x-axis, we have to square it. Then there is vertical asymptotes at x equals -5 and x equals 6. So x plus 5 and x minus 6. There is a hole at x equals 3. So we do x minus 3 on top, x minus 3 on bottom. And then there's a horizontal asymptote at y equals 3. So for the horizontal asymptote, we want the highest degree to be the same on the top and the bottom, but right now it's the highest at x plus 1 squared. And so that's bigger on top, and we can't have that. We need them to be the same so that when we divide, it's 3. That is the horizontal asymptote. So we can't make either of these squared because then the vertical asymptotes will not be correct. So we have to make these squared. So the new equation would be x minus 3 squared over x minus 3 squared, because those will cancel out, and it'll be x minus 3 equals 0, and the x coordinate of the whole will be 3. And then when we divide, since these are the same, we can divide the horizontal asymptote, and it will be 3. X plus 1 squared will bounce off of the x-axis. X minus 2 will cross the x-axis, and the vertical asymptotes will be at x equals -5 and x equals 6. And that is how you find the equation for those requirements.